Hello class, this is section 1.4. It's an introduction to identities, so let's get right to it. All right, so there's what they call reciprocal identities, so let's look at what those are. So here are the reciprocal identities. For cosecant, the reciprocal would be 1 over sine. For sine, it's basically the opposite. It's going to be 1 over cosecant. For secant, it's 1 over cosine, and for cosine, it's 1 over secant. For cotangent, it's 1 over tan, and for tangent, it's 1 over cotan. So these identities come in handy sometimes when we're trying to verify identities or just solve different problems, as you will see. So those are called the reciprocal identities, or the basic reciprocal identities, and there are also ratio identities, which just means a ratio of two other trig functions. So for example, tangent is defined as sine over cosine, but because sine is equal to y over r and cosine is equal to x over r, then when you multiply those two fractions, when you divide those two fractions, you're actually multiplying by the reciprocal. So y over r times r over x gives us y over x. So that's how we get the tangent identity. It's just sine over cosine, which turns out to be y over x if you're looking at coordinates. All right, and similarly, for cotangent, it's going to be the reciprocal of that, which is cosine over sine. And similarly, cosine is x over r, sine is y over r. So when you multiply by the reciprocal again, you will get x over y for cotangent. So these are the identities here. All right, let's take a look at some more examples, or our first example, I should say. So here's the first example. Sine is equal to negative 3/5 and cosine is equal to 4/5. Find the tangent and the cotangent. Well, we know that tangent of theta is equal to sine over cosine, which is negative 3/5 over 4/5, which is going to be negative 3/5 times 5 over 4. And as you can see, you will get that to cancel the 5s, and you end up with negative 3/4. So that is what the tangent function is equal to in this case. All right. And now we can do, well, for the cotangent, it's actually even more simple, because once you have tangent, cotangent will just fall into place. You simply need to take the reciprocal of this ratio. So for cotangent, you could go through the same steps if you prefer. You would just have to put the sine on the bottom and the cosine on the top. And so you would, reverse these two fractions. But the easier way to do it would be just to take the reciprocal of that ratio, which turns out to be negative 4/3. All right. All right, let's move on to the next example. And now there's what they call the Pythagorean identities. And the reason they call them the Pythagorean identities is because they use the Pythagorean theorem to come up with them. So for the first one, you have cosine squared plus sine squared is equal to 1. Right? And that's just because of any angle that you're looking at, you can form a right triangle with that angle. And so on a unit circle, we already know that the hypotenuse is 1 on the unit circle. By definition of the unit circle, unit 1, radius 1. And so this becomes your cosine, this becomes your sine. And so now a squared plus b squared equals c squared. And that's where this comes from. All right, an equivalent form. Well, if you're to solve for cosine, you would subtract sine to both sides. We can actually do that over here. Oops. And so when you solve for cosine, you're going to subtract sine squared to both sides. And then you'll get cosine squared equals 1 minus sine squared. And then the final step would be to take the square root of both sides. And then that's how they end up with cosine theta equals the plus or minus of the square root of 1 minus sine squared theta. So whenever you take the square root of both sides of an equation, this always gets introduced, this plus minus, so careful not to forget that. All right, and the same goes with the solving for sine. So that's where these two come from. And then these other two come from, well, once you have this Pythagorean identity, you can always divide both sides of the equation by cosine squared. So if you do that, let's see what happens there. Whoops. Cosine squared all the way through. And then this will turn into a 1. This will turn into tangent squared. And this will turn into secant squared. And so that's how you can derive this next identity. And then similarly, you can do the same thing to get the last identity. Instead of dividing by cosine squared, you would divide through by sine squared. And that's how you get this one. All right, so if we do that, you're going to get, let's start with the original identity and divide everything through by sine squared this time. So now this becomes cotangent squared by definition. This becomes 1, and this becomes cosecant squared theta. And so that's how this identity is derived. It doesn't matter that the 1 is switched or is switched with cotangent squared. Addition is commutative, so these two you can reverse those. You can reverse the order; it doesn't have any effect. All right, so these are pretty important theorems here, or I'm sorry, identities. So I'm going to highlight them. This one, and this one. All right. So let's see how we can use them to solve this example. If cosine theta is equal to 1/2 and theta terminates in quadrant 4, find the remaining trigonometric ratios for theta. Okay. So I always like to draw a right triangle in the correct quadrant. So we are in quadrant 4, so I'm going to draw an angle in quadrant 4. So this is 1, 2, 3, 4 is down here somewhere. Theta would be there. Theta is always going to be between your hypotenuse and the x-axis. All right, and you just want to make sure you're in the correct quadrant. All right, and so now we know that cosine is adjacent over hypotenuse. So adjacent would be 1. That would be your adjacent side, adjacent to the angle. And then hypotenuse is 2. Right, and now we can use a Pythagorean theorem to find the missing side. So let's do that. So we got, I'll call this b for now. So a squared plus b squared equals c squared. So 1 plus b squared equals 4. Subtract 1, b squared equals 3. B equals radical 3. We can disregard the plus minus or the minus in this case because we're dealing with lengths and lengths are always positive. So you don't need the plus minus in this situation. All right, so now we know that this is radical 3. All right, and now they want us to find the remaining trig ratios. All right, well, let's start with sine. Well, we know that sine is opposite over hypotenuse. Oh, we do have to be careful with the signs here. Let's see, positive, negative. Actually, yeah, we have to be very careful, actually. We're going in the negative direction, so even though the length is positive, it's going in the direction in a negative direction, so you have to be aware of that. So this is actually negative radical 3, not positive, because you're going down. All right, so positive, negative. All right, so sine would be opposite over hypotenuse. Negative radical 3 over 2. All right, tangent is defined as opposite over adjacent. So that would be negative radical 3. And then the other remaining trig functions, we can simply just take the reciprocals of the ones that we already have. We already have cosine, it's given to us. So secant is going to be the reciprocal of cosine, which is 2. All right, cosecant is the reciprocal of sine, which is -2 over radical 3. In this situation, you don't really have to rationalize the denominator. You can if you want to, but Webosine will mark it correct either way. So it's up to you whether you want to rationalize that denominator or not. All right, and for cotangent, which is a reciprocal of tangent, you would take the reciprocal of negative radical 3. That would be -1 over radical 3. All right, and there you have it. Those are the remaining 5 trig function ratios. All right. There's a total of 6, but this one was already given to us, so that's why there's only 5. All right, moving on. And actually, that does it. Let's take a look at some of the homework problems. So here are some of the homework problems. I'm going to skip these fill-in-the-blank problems. I think you guys can figure those out, hopefully. Match each trig function with its reciprocal. I'll let you guys do these two because these are just definitions. All right, let's take a look at number 3. Use the reciprocal identities for the following problem. All right, well, cosecant, we already know cosecant is the reciprocal of sine. So if the ratio of sine is 7/8, that means cosecant would simply be the reciprocal of 7/8, which is 8 over 7. All right. Use a ratio identity to find cotangent of theta given the following values. All right, so in order to find cotangent, by definition, we know that cotangent is equal to cosine divided by sine. So in this case, we have cosine, which is -21 over 29, divided by sine, which is -20 over 29. And now when you multiply by the reciprocal, you're going to get -21 over 29 times, I use parentheses here, the reciprocal of the denominator is -29 over 20. And we get this nice cancellation. And you have a negative times a negative, which is a positive. And you end up with 21 over 20. All right, so that's how you would do number 4. Let's take a look at some other problems. All right, they're saying here that sine squared of theta means the same thing as sine theta parentheses squared. That is the same, that's equivalent. Those are just two equivalent forms of writing the same thing. All right, so if they give you the ratio of sine and they're asking you to square it, that means you need to square this ratio. So it turns out to be radical 7 over 3 squared. When you square a radical, the radical and the square cancel each other out, so you're just left with 7 in the numerator, and then 3 squared. 3 to the second is 9, so that is your final answer for that one. Let's take a look at a couple more. There's only 10, I believe, here. All right, number 6, they want us to find the tangent. I'll go ahead and let you guys do this one. This one is tangent. I'll just start it off for you. We know that tangent is, by definition, sine over cosine. And so you would take your ratios that are given to you and divide those two fractions. All right, so whatever you end up getting when you divide, that's your answer there. All right. Here they're asking us to find cosine if sine is given to us, and they tell you what quadrant the angle terminates in, quadrant 2. So I'm going to draw a right triangle once again in quadrant 2 somewhere. It's probably not drawn to scale because I just drew a random angle in quadrant 2. So the ratios are not going to be drawn to scale here. So we know that sine is opposite over hypotenuse, so opposite would be here. Just be aware of the signs. Positive, up is positive, down would have been negative. So that should be a positive, and then hypotenuses are always positive. All right, so that would always be positive no matter what quadrant you're in. So now we just need to find the missing side here. All right, so I would do Pythagorean theorem. So a squared plus b squared equals c squared. So that's going to be, I'll call this a for now. A squared plus radical 3 squared equals 2 squared, which means that we have a squared plus 3 equals 4. A squared equals 1. And a equals plus or minus 1. Well, because you're going to the left, not the right, that means that this should be a -1, not the positive 1. So I'm going to just put -1 there. So it's just very important that you're aware of whether it should be positive or negative depending on the direction that you're going. This is going to the left, which makes this a negative value. All right, so cosine is, by definition, adjacent over hypotenuse. So there you go, -1 over 2. All right, let's look at number 8. This is a good problem. They're telling us that, I'm going to create some space here. They're telling us that they want us to find cosecant given the cotangent, right? And they also tell us that sine is positive. All right, so we got to figure out what quadrant that would lie in. Well, let's draw a coordinate plane. So cotangent is negative in this quadrant and this quadrant because it's by definition x over y. And x over y would be negative in these two quadrants. So quadrant 2 or quadrant 4. But they also tell us that sine has to be positive. Between these two quadrants, we know that sine is positive in this second quadrant because sine is equal to y. And y is positive in quadrant 2, and it's negative in quadrant 4. So that pretty much tells you the quadrant where your angle terminates. So quadrant 2. So once again, just draw any random triangle. There's your angle. And then we know that cotangent by definition is, instead of sine over cosine, it's cosine over sine. Or you can think of it as x over y. All right, so x would be this one, y would be this one. So x would be -28, y would be +45. All right, and now we need to find the hypotenuse. And to do that, we just need to do the Pythagorean theorem again. So I'll call that c for now. So you got -28 squared plus 45 squared equals c squared. So using our calculator, we should get I'm getting 2,809, and so the square root of that is 53. All right, so now we have the hypotenuse, and now we can go ahead and find the cosecant, which instead of, it's a reciprocal of sine. We know sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. So 53 over 45. So you just have to become very familiar with the definitions of cosecant, secant, cotangent, and so on. All right, let's look at this one. All right, so similarly as in the previous problem, they don't tell you directly or explicitly what quadrant the angle is in, but they tell you it's not in quadrant 3. And since sine is negative, that narrows it down to a quadrant that we should be able to figure out. So let's see, sine is negative in these two quadrants because it's the y coordinate, which is down below here. And so it's got to be this one or this one, but it's not in quadrant 3, so it has to be in quadrant 4. So therefore, we can draw our angle in quadrant 4 somewhere. Theta. Remember, theta is always between the hypotenuse and the x-axis, always. This is opposite hypotenuse. So opposite is negative radical 3 because it's going in the negative direction. Hypotenuse is always positive. All right, and then we can find the missing side once again by doing the Pythagorean theorem. A squared plus b squared equals c, whoops, got that backwards. A squared plus b squared equals c squared. So that's going to be a squared plus 3 equals 4. A squared equals 1. So it's got to be positive or negative. And because a is going to the right, that means it's going to be positive 1, not negative 1. All right, so. All right, very good. Now we need to find cosine. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Whoops, opposite over adjacent. Sorry, that's just negative radical 3. Cotangent is a reciprocal of that, or you can look at the triangle, 1 over negative radical 3. The negative, you can place the negative in the numerator, the denominator, or right in the middle. I always like to put it right in the middle. Secant, well, that's just a reciprocal of that, of cosine, so that's going to be 2. And then cosecant is the reciprocal of sine, which would be negative 2 over radical 3. And once again, you have the choice of whether you want to rationalize the denominator or not. It's not required, but it would be marked correct either way, whether you leave it in this form or whether you rationalize it. All right, the last problem looks like this. Using your calculator and rounding your answers to the nearest hundredth, that's very important. Otherwise, WebAssign will mark it incorrect. It's very particular as to how they want their answers inputted. Find the remaining trig ratios of theta based on the given information. Okay, let's see here. So what you can do here in this case, there's a couple ways to go about this one. Let's see. Well, they tell you what quadrant the angle is in. It's in quadrant 1. So let's just draw that. All right, so I'm going to use the Pythagorean identity, since that's what we covered in this section. So we know that the Pythagorean identity is sine squared plus cosine squared equals 1. We already know what sine is, so that's good. We'd put that here. So that's going to be 0.028 squared plus cosine squared is equal to 1. So now we can use our calculators here. So you should get 0.0784. And now when you subtract, you end up getting cosine squared equals, what is that going to be? 1 minus that is 0.9216. Then you take the square root. And so you end up getting cosine theta equals, the square root of that number is 0.96. Now we got to figure out whether this is positive or negative. Because we're in quadrant 1, as you can see, the angle is in quadrant 1. Cosine is positive, and so is sine. They're both positive, so therefore this would be your answer for that. All right. Now, once you have sine and cosine, the rest of these should be pretty straightforward. So to get tangent, you would do sine divided by cosine. All right. So tangent is sine divided by cosine, which in this case would be 0.28 divided by 0.96. And you should get a repeating decimal, and they want us to round to the nearest hundredth, so that would be 0.29. That would do it right there, 0.29. All right, and then for the rest of these, you could just take the reciprocal. So the reciprocal of tangent would be your answer for cotan. The reciprocal of cosine would be your answer for secant. And the reciprocal of 0.28 would be your answer for cosecant. I think I meant to say secant, not cosecant, for the previous one. Well,